For number 4, you're told that there are 3 possibilities for a vehicle to take. Either it will go straight, or it can take a right, or it can take a left. The probability for taking a left is 0.3. 30% is 30 over 100, 0.3. The probability of turning right is 0.25. And probability of going straight on would be 0.45. If you add all of this, I think you get 1, because these are the only 3 options. It's not a geometric distribution. It's not even a distribution yet, because it hasn't described anything to you. When do you know that you're taking binomial or geometric? For geometric, you need to get successes. You need to stop at a specific failure. Stop at a specific success. First success. For binomial distribution, you have a sample, which means that you will repeat the event a specific amount of times. I'll take an example. Let's say I'm throwing a coin. How can I turn this event into a binomial? And the same way I can turn this same event into a geometric, but it's not the same. For a binomial, I will say let's say I throw the coin 6 times. So the amount of times that I'm throwing the coin is fixed, n equal to 6. I'm not going to throw more, I'm not going to throw less, I'm going to throw it 6 times. And I'm going to tell you find probability, let's say, of obtaining 6 heads, or 3 tails, 3 heads, something like that. But the amount that I'm going to throw it would be exactly the same, would be n equal to 6. It will be fixed. I will say I'll throw it 6 times. I'm not going to throw 7, 8, no, 6 times. For geometric, I can throw it any number of times until I get my first success. So how do I turn this geometric? I say I'm going to throw the coin. I'm not going to say 6 times or 7 times. I'm going to throw the coin until I get, let's say, a head. And how many times can I throw this now? It's unlimited. I can throw it 5 times and then I get a head. I can throw it 6 times, then I get a head. I can throw it 8 times and I get a head. This makes it geometric. So geometric, you have to understand the meaning of it is that I'm going to do an event until I get my first success. For this event, the first one, there's no limitation on anything. What it has told you is that find the probability that the next 3 vehicles approaching this junction will go in different directions. It hasn't told me specifically it has to go left or right or straight on. There's no specification. This is not geometric. This is not even binomial, because for binomial you need a specific probability. Here there's 3 different probabilities, so it's not geometric and it's not binomial. What I'm going to do is, this is actually a normal probability question. There's permutation in this. What happens is that I have 3 vehicles, car 1, car 2 and car 3. What I need is for each one to go in different directions. So the probabilities have to go 0.3, 0.45 and 0.25. I just have to rearrange them, because I can get to 0.45, 0.3, 0.25 here, or there's different ways that I can rearrange this. This is actually a permutation question, because I'm going to rearrange these through. So the probability would be 0.3 times 0.45 times 0.25, because I'm going to arrange them. And how many places do I have? I have 1, 2, 3 places. 1, 2, 3. It will be 3 factorial. So it will be 0.3 times 0.45 times 0.25 times 3 factorial. Then you'll get your answer. This is simple permutation question with probability. Why 3 factorial? Because they're telling me that each car has to be different. If each car has to be different, if the first one goes, let's say, left, so it's 0.3, and then the second one goes right, 0.25, then the third one can go straight, 0.45. These are my probabilities, car 1, car 2, car 3. Now I can rearrange this. Actually 3 factorial is 6, so I get 6 possibilities I can show you. Let's say I keep 0.3 here, then I swap the other two, 0.45, 0.25. I can put 0.25 in the first one. My second one would be 0.3, 0.45, or 0.45 and 0.3. Then the last one is, the first one goes straight ahead, then the second one goes here, the next one goes right. The last possibility would be this one. So in all I get 6 possibilities. Sorry, but I'm not going to calculate all of this, it will be very long. What I can do is I just use permutation. I take 3 places, rearrange 3 numbers a, b, c. I have 3 places, so it will be 3 factorial times all of this. 3 factorial is actually 3 times 2, which gives you 6. That's why we got 6 possibilities. For the next question, find the probability that from the vehicles approaching this junction, from the first one will go left. So it has specifically given you a new probability, which would be 0.3. This is correct. This is correct, 0.3, geometric 0.3, and then Q is 0.7, but your calculation is incorrect, because remember I told you last time probability x less than 9 is 1 minus p power 8. So you're going to get 1 minus 0.7 power 8. You don't multiply these two. What you're doing here, this is not probability x less or equal to, this calculation is for probability x is equal to 9. Then you're going to take and even this is incorrect, because you have to take 8 failures and then only 1 success. What you did is you took 8 successes and 1 failure. When you're saying geometric 0.3, this is your success. 0.3 is the fact that you're going to get this answer. This is your answer and you're going to calculate this. This is a bit tricky.